This conference will now be recorded.
Thank you. So, what is that we were doing in last session? You remember, right? We were working on this stuff actually, array stack and stack. Today I told you we'll talk about a couple of things. List over immutable list. There is one more thing, and then also we need to talk about few other implementation classes. Let me just directly get into the hierarchy here. See, a small request to all of you, right, folks. Right, it's not like I don't want to. It's not like I'm offending anyone here. But the point is, what I'm seeing is the questions. So I request all of you, please, whenever you have a question, first Google it. Then still, if you don't understand, then what happens? And or if it is really good, difficult to understand, then ping in the group. So if not me, somebody else in the group might help you. Okay, so that will be a good approach. I'm just suggesting, but it's up to you. I'm not making any restriction here. But let's make sure let's value other people time also. That helps others to cut short the time. Got it right? So that is only my personal request. So here we're talking about this stuff. Let us take this. We were talking about the sequence hierarchy, right? One is we have done stack, array stack. We know the difference between linear sequence and indexed sequence. Today I told you we'll talk about mutable list. Then the other one is list buffer. Probably it should be somewhere here. So list buffer here. You see the implementation of buffer here. In this hierarchy, there is one more extra trait added comparative to not one, two more extra traits are there in this hierarchy. So if you go to the immutable collection hierarchy, we have sequence, indexed sequence. We have almost three traits in that hierarchy. A sequence is parent, and linear sequence and indexed sequence are childs here. That's what it is in that immutable collection. But coming back to this hierarchy, we can see more traits involved into this hierarchy. So we can see there it has a linear sequence, indexed sequence, buffer queue, all this is there, right? So now the question is, so what is this here now? Now today I'm going to focus on a few important areas. What is that? List buffer, and then also mutable list, and then synchronized stack. Okay, apart from synchronized, and then queue. I will discuss quickly about queue and W link list. One more is, then I think we will switch to the next hierarchy. Observable buffer is also, these are also, even you can see there synchronized buffer, observable buffer. Even these are traits. Just keep in mind. If you want to ignore them, not an issue. Okay. So that's the idea here. All of you are clear, right? Got clarity here now. So that's the simple analysis. Now, let's start from here. So, what is this list buffer here? It's actually, right, we are talking about mutable collections. So, when you talk about list buffer, it's same like sequence, it's dynamic. So, and also, what is that? Insertion address preserved. And then also, we can have heterogeneous elements, we can have duplicates, all that is fine, okay? And this is actually an IMPL class of buffer hierarchy, okay? So when you look at it, we have a buffer here, if you see there. Under buffer, we have this list buffer, okay? It's an IMPL class of buffer actually. And buffer is a child of sequence, that is it. You can see that it's very straightforward. So now the point is, what is it? Second thing, it is dynamic. And one important point, because I just only made the very important point. See, what exactly is list buffer here? It is an implementation of buffer which is backed by list. Here you can see there list buffer has actually internally list has an underlying data structure. That is very important. Okay, other things are fine. It's dynamic, it's heterogeneous. Okay, and then insert order preserved, because this is part of a thing, right? This thing like sequence. When you say sequence preserves insertion order. Second thing is it will allow duplicates. These are the core features of this one here. Okay, other things are fine. Now we don't have. Okay. Got it, right? So insertion order is preserved here. Now I don't know. Insertion order preserved. Then duplicates. Then also it's heterogeneous. All this is fine. Okay. Anything we can add to this apart from this? It has an implementation, and it is an IMPL class of what? IMPL class of buffer. Okay, buffer is a trait actually. So that is a trait. Right. So this is a simple analysis of list buffer. We'll quickly check test it. Let's analyze this. So just create a buffer object as this buffer equal to list buffer. You can create some empty buffer and you can keep adding elements by applying that operators, that plus and minus operators. Else you can directly pass elements to the buffer like this. Just for analysis, I am adding duplicate elements. Okay, and then of course you need to import it. You should say here what is that list buffer. Next, then you can just keep printing this. Okay, just print it and see the, just observe the features how it works. Okay. Just run the program, and you can say everything is intact. You can keep adding elements how many you want. Insertion order is preserved and duplicates are allowed. And if you want, you can add some heterogeneous data. Okay, some ABC. I'm just adding string just to show that we can have heterogeneous data. Heterogeneous means different types of data, different kinds of data. Okay, we can have that heterogeneous data. And that's it. Other things, anyhow, you know how to add element, how to remove element, how to iterate it. Okay. All that stuff is known to you. I'm only just focusing on understanding every implementation class, what will be the underlying data structure, what will be the performance differences. That is one thing we just focus. Okay, so that is the idea about this program. So please test it. Yeah. Please mute your machine. Somebody, I don't know. Just right. This is the idea about this thing. Okay, if you want to have a quick notes of this, you can copy it. Make a note of this stuff, because test it quickly. Just observe the thing. Okay. Hardly a minute. Okay, because we don't have much. No, we just started with this only, Madhu. That's all. I just have shown the hierarchy. That's all. Just go on to the diagram and just we have analyzed the implementation classes. That's all. Nothing much has been discussed. Nothing important is being discussed. Just test it, sir. Probably I will now talk about a couple of things here. Okay. There are a couple of points we need to add to this. So why do we need list buffer? That is the first question in the front line. So the first thing we need to understand is why we need list. That is one thing. So what is this buffer? So buffer is again it's a child of this I mean sorry, right, indexed sequence. Okay, if you look at here, you can see it's a sorry, sequence. Sorry, I think I got confused. Sequence, that's fine. And why list buffer here? Maybe if you ask me, the simple thing is, have you ever heard of list? I think I should not ask this question. Why? No, where did you hear about list? Anybody just can ping on that? Can anybody tell me where did we use list? Do you have list in mutable collection? That is my question. Do we have a list in mutable collection? That is question one. Question two. Where did we had discussed about list? When did we discuss? Which hierarchy has list? Answer. Answer, sir. Which hierarchy has list? You have no, Sandeep. Yeah, list is immutable, correct. It's in which hierarchy? It's in immutable collection hierarchy. Suppose when it is immutable, you cannot modify it. Suppose you want a list, but it should be modified. Then we have to use list buffer. In fact, in a mutable collection, something you want which is something parallel to list is list buffer. And you clearly see that this list buffer uses right, a list internally. So if you want something mutable list, then it should be a list buffer. Got it right? So that is one thing. Got it right? And there is one more thing always happens here. So what is that point is, sometimes we know we need to convert these mutable collections to immutable. And you can convert immutable to mutable also. You can do both ways. Okay, it's not like it's a one way direction. So then suppose usually it's always people always do like this. What is that? If we need to create something, right, constantly changing, and if you want to modify something constantly, then probably instead of list we prefer list buffer. That is one thing. Okay. And second thing is one more important point is right, what list does? List will build your elements from back to front. You got the point right? So back to front means what? You keep on adding elements from what is that? When you want to prepend elements, then you go for list. You remember that point. Okay. So when you want to add elements from back to front, right? We use list. Similarly, in mutable collections, what is that we use here? List buffer. So it is something which is used to build your collection from, I'm sorry, I think I told back to front, right? It's a mistake. Front to back. Okay, front to back. So let me correct my statement. So I'll write here. If you want to build or create a collection, or so that if I write it, we don't have any problem. Create a collection from front to back. Okay, right. Then we prefer what? We prefer list, which is immutable. That is one thing. Suppose I want a mutable version of that, then we go for list buffer. That is another important thing. What else? What else is there? Then so I think front to back. One minute, give me a minute. There's a big confusion. Let me add list buffer. So let me write it. This is back to front. Let me write it. So this is front to back. Now it's perfect, right? You got this point right now. So if you want elements from back to front, okay, where from back to front, if you want to construct a collection, then we prefer list. And what list buffer will do? List buffer is used to build or create a collection from front to back. That is the difference. And also one more important thing, if it is list, right, it is efficient if you want to prepend elements. When list is efficient, if you want to prepend elements, then a prepend operation, okay, you want to go for prepending, then this is efficient. We had discussed this in the very beginning, okay. But list buffer, right, in the other way, okay, on the other side here, when you talk about list buffer, this is used to prepend as well as append. Prepend and append, this is used in both ways, right? That's what documentation is saying. That if you ask me why like that, the process that makes these small differences are here. Just try to figure out the differences, one thing, how they are getting constructed, when it is best fit. I told you, right, these differences we need to know. But while doing coding, right, these are all necessary to make a decision which data structure to use based on your data. But when you start doing coding and applying methods, this analysis is not necessary, okay, because there you focus more on logic. You got my point, right? I think this is clear. All of you are clear with this discussion, no? What exactly the difference between list buffer and what is that list? So list is immutable, list buffer is mutable. That is one thing. Second thing, we cannot modify list, we can modify list buffer. Third thing, if you want to construct a collection from back to front, we go for list, and this is best fit for list is best fit for prepending, which is used to add elements at the uh, beginning. That's why. And list buffer is what? If you want to construct a collection from front to back, right, from beginning to the ending, then we prefer list buffer. And this is best fit when if you want to perform prepend and append operations. You got it right? This is simple idea. And one more thing is it's very easy to convert a list buffer to list also. So there will be two list method, and when you apply that, automatically we can do the casting, that upcasting, and the casting of from list to list buffer can also be done. Maybe I'll just quickly show you here. Suppose we have constructed this, right? You see now, and this all has indexes. Okay, one more important point is, as these classes are kits of sequence, you can extract elements through index like this. Okay, this will work. Okay, for all sequences, you can see that I got one from there. Okay, that is fine. Second thing, I want to convert another important point. A list buffer to, sometimes we need to convert mutable to immutable. List buffer to list. And the easiest way is what you can simply say something like val some list equal to. I can simply say buffer dot list. Can you see that? Now print. This is a pure list now. Once you apply that casting, that becomes a list. So this is also possible. You see that? Okay, now you can see the difference. Now list buffer got converted to list here. And another important thing, suppose val some, I'm just trying to do the other kind of conversion. Buffer to equal to list dot. Let me check. Do we have a to list buffer? See, we don't have this conversion, but the possible conversion is what, sir? Here, I'm just trying to check in the program itself so that the point is we can convert list buffer to a list. That means a mutable collection to immutable collection here. But the opposite we are not finding here. We don't have a method to do that. Okay, so that's also important thing we have to observe here. So this is one more important point you can. So generally, once you build a mutable collection with list buffer, we can convert it to a list by applying this casting method. Okay. This is also one more important thing you can add to the this thing. What it makes. Are you good with all this analysis? Are you good with all this analysis, sir? All of you are clear? I think all of you are clear. And anybody has any questions? Clear, right? Okay, I'm moving to the next one. Do you want to quickly check this? I don't think this is too difficult here. Similarly, you can apply all other methods. Understood? You can apply all other methods like plus colon plus equal to minus equal to all that. Okay, right. So next one after that is I'm moving to the next topic. What is that? Mutable list here. Mutable list means you can see the hierarchy again. Let me just show you. Can you see here now? It is a child of linear sequence. And it's very clear here. It's clearly saying that it is an implementation based on what's a linked list. And it is saying that one more important point is the difference is simple between list buffer and mutable list is, this is why I put it here. They were clearly saying that what is that? It would be more self-explanatory if it had been named as linked list buffer. Means difference is maybe there is a question now. Difference between list buffer and mutable list. List buffer internally uses list, whereas mutable list internally uses what? Linked list. You got the difference here? So, and few differences between these two. And another important point is you can see here now. What is that? This list buffer is final or sealed. You know what do you mean by final, right? We cannot inherit it. Whereas mutable list can be inherited. It can be extended. Okay, that's possible here. So this is also one more important point you need to concentrate. What is that? When should we go for list buffer? When should we go for mutable list? Okay. The point is simple. Even though both are belonging to the sequence, to the class of sequence, point is this mutable list can be extended, whereas list buffer cannot be extended. So if you want same qualities of list buffer, and if you want to extend something, then you should prefer which one? Mutable list. That is also important. This is the very core difference between list buffer and mutable list. What is that? Internally, this uses linked list, whereas list buffer uses list. Is that clear? The program thing you can easily test itself. Instead of list buffer, you can put what here, sir? You can simply say mutable list here. Okay, here also what is that you can do, sir? Just put the mutable list. So, other stuff is again probably, if I'm not wrong, the things were again the same for even for mutable list. Even mutable list has a method to convert to the list. This whatever the mutable stuff you can convert to an immutable list by applying this here. Okay, and also maybe I'll just try the vice versa. Can we have something, a list which can be converted to mutable list? Probably I don't think we have such method here. So that too, we don't have that. You see, generally, if you observe here, most of the methods which are targeted here are converted, are used for converting mutable stuff to immutable stuff. Maybe we will check the if we have any other methods which can be applied in the other direction also, in vice versa. Like, if is it possible to convert an immutable to mutable also? We can also check that. Okay, maybe probably the possibility should be like this. I'm just adding some sequence. Convert list dot to sequence. I can bring it to sequence. That is one thing. Then from sequence, well, I'm just doing a workaround here. Just observe, sir. Okay. Sequence 2 equal to sequence 1 dot. Can you see here? To buffer. Can you see here? Maybe we can do like this. Even one more thing here itself. Let me try. Can we do it conversion to buffer itself directly? To buffer val buffer equal to list dot. We don't have on this. Can you see that, sir? I cannot directly convert to buffer here on list, which is immutable one. So there is an indirect approach. What is that? First, I can convert it to sequence. From sequence, then you can see there. You can see the pre-indexed sequence. Can you see? Observe that. Now you have a possibility to convert it to mutable collection. Can you see it? So means we have to come in indirect approach for the conversion. Okay? See now. Now buffer is no doubt. Buffer is what, sir? Is it mutable or immutable? It is mutable. So this is how, if you want, you can bring back it to your actual again mutable stuff by doing some intermediate steps here, applying some intermediate step conversions. I think this is clear, right? Following, sir. All of you are good, sir. Is it clear now? So that's the idea about this one, about mutable and then the other conversions. Probably I'll try one more last one. Simple workaround I'm just doing in order of just curious case. Then let us just test it here. Probably this is the end. We don't have something like exclusive to what is that, two mutable list or two list buffer. Probably internally it might be using, maybe let's print this. Let us print all this stuff to get an idea what internally, what data structure it is using. That gives you a better idea. Now, right, sir. So this is how we can just, what you can do. We can keep on drilling it, the code. If this happens even in real time. So, got it right. The analysis thing is very important. So nowadays, even in interviews, people are asking technical written test questions. No, I'm doing a couple of written tests as well. Now you check it out. Now you get some idea. So what's happening here? Probably maybe I'll just print. Otherwise you don't get quick idea what exactly it is using in which case, so that we get some quick understanding. This is one. And here also, let me just copy and paste. Observe here, sir, how you can keep getting information, like how do you extract info. So again, it's my mistake. Sequence 2, sequence 3. What exactly internally it is using? For sequence 1, you can see when I convert list to sequence, still it is using internally list itself. When I convert sequence to buffer, you can see it is using array buffer. You can see buffer is using array buffer. See, in the case 3, I didn't put anything here. Okay, so when I say just 2, it is doing, it is giving me the vector. Vector means which is a child of what? Indexed sequence. So the third one, why I put this, I really don't remember. So this is okay, fine. We can leave it. Default it is taking vectors. You got clarity now? So now this is the point here. Finally, when you get into the discussion, okay. So what's happening here? This buffer internal uses what array. That is important. Got it, right? This is how you should get into the root of this, right? Information. Usually, what happens is people don't talk at this level. People's discussion will be at this level, probably just how to extract elements, how to this this level. What is that? When you at least people will just do up to this, but they don't again. What is that? When you do convert it, what kind of internal data structures it is using? All this matters to you, sir. Maybe you understand that at some particular point of time. If you want to become an architect, then your focus should be not just understanding syntax or understanding a simple theory, but getting into the analysis, like the performance things. Now you are seeing, right? So this thing, of course, we can do more on this, but I'm just at least trying to make these points, like what exactly the difference between these two. When should I prefer list? When should I prefer list? When should I prefer mutable list? Okay. Now at least I have some information on that. At least I can tell you. Okay. So if you want to have some inheritance, but it should be mutable, go for mutable list. If you don't want to extend, but it should be mutable, then go for list buffer. Okay. And if you don't want any change, but it should have some what is that best fit for prepending, go for list. Like that, depends on the situation and the necessity of a data structure. We need to use it. You got it right, sir? So this is a crime analysis, sir. So can you please just make a note or testing? Can you please test this once? The idea about mutable list. I'm just adding the code here. Then I'll talk about synchronized list. Maybe if possible, I'll add 1 or 2 points after this. Where's this program? Please test it, sir. While doing, just analyze it, understand it. Okay. Is it done, sir? Okay, fine. Next, let me switch to the next discussion. So we can come back to this again. Today, we will discuss one more, synchronized stack. So for this at least you need to have some idea about what is that is. I would like to quickly bring in this synchronized prefix thing. All things which were synchronized. So means these were thread safe. What is it, sir? These were thread safe. So I will add here. Okay, synchronized stack. What is this? It's again a child of stack. One thing if you see in the hierarchy is a child of stack. Then it has almost all the features of stack. But what is that? But what is the difference here? This is synchronized. What is synchronized? Synchronized means even synchronized queue or synchronized anything with synchronized. The what all this means is you need to know this very important thing. Okay, because suppose in a Scala, if you are using any multi-threaded thing, Spark uses lot of multi-threading. It creates lot of threads, but we don't know because we are not the one who implemented that framework, right? Still, right? Internally, it uses lot of threading. So what is synchronized stack means? It is similar to stack. That is one. When I say similar, then why again that question comes is but. So I am adding but it is thread safe. What is it, sir? It is a thread safe. Then again a question from you. What is thread safe? Let me quickly explain this. Okay, I will explain here itself. Quick idea. Suppose I have an object. What object? I have something like a superhero object. Okay, let me just add an object here. I'm just saying superhero. This is my object. Right, superhero means there is a lot of dependency on superhero, right? Because whoever is weak, they need the help of superhero. There are people like P1, okay, P1, P2, like that. Okay, I'm just giving you some analysis, okay, and then P2. This is one more, and then P3. This continuously. Now if my object is a superhero, it is belonging to a class called superhero with some characteristics like the color, height, okay, powers. We can add some kind of attributes to that. Okay, just giving an idea. Now I created an object and applying a threading on. Assume that these are threads. Okay, what is that? P1, P2, P3 are threads. Thread is a small independent program. That's what thread is in a quick discussion, which performs a specific task. That's what thread is. And group of threads executing parallel is called multi-threading. Now I have an object. Now all the threads need to access this object, which is superhero, P1, P2, P3. Now the point is what? How many objects are there? One object. But how many threads are there? Three threads. Now suppose if we don't have synchronization here, assume that's where the concept of synchronization comes here. I don't have a synchronization. Now P1, P2, P3, everyone is coming at a time and falling on this hero. It will be very difficult for this guy to service these people, right? P1 has a problem, P2 have a problem, P3 have a problem. All are having some issues here now. The villain is making them feel bad. Now who has to help? Superhero. Now what is that? Everybody came and started pulling this guy. Then what happens? This becomes inconsistent here. Why? He may not listen to P1 or P2 or P3. Now what happened? We kept a synchronization here. Earlier we don't have a synchronization. We kept a lock concept. What is that? Now among these three, one should have a lock. Whomever comes first or who has high priority, assume that it depends on different priorities. First come first serve or highest priority thread or some other thing. Last come first serve, something like that. There will be some kind of priority to threads as well. Now we don't know who gets priority here, but this P1 got assumed that this P1 has acquired a lock on this thread. Okay, whenever you have a synchronization, there is a concept of lock. So when you have a lock concept, who got the lock now? Assume that P1 got a lock. Now once P1 got lock on this object, the other two threads have to wait. Who has to wait? The other two threads should wait until P1 finishes its execution on superhero. Okay, once the problem of this P1 is resolved, then P1 will release the lock and that lock is given to P2. Are you following, sir? So now what happens, sir? Now again, P2 will go to the superhero with the lock, and he will take the service of superhero here, this object, and then again it will release the lock. Then it will come to P3. And this scenario, what we call it as synchronization. Synchronization means when you have an object and when you have multiple threads running on that object, at a time only, what happens, sir? At a time, only one thread is allowed to access that object, and remaining threads has to wait. In this situation, we call it as synchronization. And when you make a stack as synchronized, this threading concept, this lock concept is applied on that stack, so that multiple threads don't directly go and try to execute that object, stack object, because when it is done, right, what happens? There will be a data inconsistency issue, because we don't know, all these three are fighting with each other. These are in race condition, and we don't know which will execute first, which will later, which will be after that. Then this leads to a inconsistency issue. So to resolve these issues, this people like Java and this this Scala people, they came up with the concept of synchronization of threads. Okay, so that's what synchronized stack is, where a threading is applied so that at a time one thread is allowed to access the object, remaining threads are wait. This situation we call it as thread safe. Is that clear to you, all of you? Is that clear to all of you, sir? Can anybody confirm? Can anybody confirm, sir? You understood this or not? Or did I make you fell asleep? No, right? All of you are awake. Got clarity? That's what it is, sir. Other things, whatever properties of stack, you can copy and paste that. Now I am not doing again one more time. And maybe if you want, just look at the APIs. We'll do one thing. Just always I like this actually. This is how I learned, the deeper analysis of Java, all this stuff. Synchronized stack. You can see there is a synchronized stack in Java also, but we don't want in Java. What is there we need in Scala. So directly we have an API available. The other thing is not available for us. That's enough now. You can see the right. Implements a data structure which allows to store and retrieve objects in last info. We know about all that stuff. I just want to show you a couple of methods here. Okay. Probably if they were using any keyword synchronized like in Java. So by default, these methods from here will be, see, you can see that everywhere, all these methods are synchronized. You don't need to put any keyword here in Scala just to make it synchronized. But by default, the methods are what? Doing sync, are actually, what is that? Using this synchronization implicitly. See there, everywhere we can see they were just, what is that, whether your every method they are using that synchronization thing stuff. You see there, right? So this is simple analysis. So these methods are exclusive, which performs more on the synchronized stack. You can see there. And you know what is synchronized stack means? We had a detailed analysis. Maybe you can just quickly test it. Other stuff is just for SS. SS means synchronized stack. Synchronized stack. This is what I need. You can see it is duplicated. So if it is duplicated, we don't need to worry too much about such kind of data structures. Okay? Because they are outdated. They are Bajaj Chetak as per Indian, no, this thing. 1 minute. Not found value synchronized stack. can see a default constructor here. So when you have such doubts, you can check the constructor. Okay, I should apply new operator here. It's expecting new. Let me apply new. It's not depending on companion object. So see there. So when you know the API, so you can understand the problem. See, usually when I directly create like this, if I don't have idea about API, then I cannot resolve this, because if you don't have this habit going into this and checking the constant, this is a constant. And see now, as I have this clarity, like this is how, okay, the constructor is a different here. Whenever you have such issues, also check the constructor here. This, you have a lot of list of constructors, not just one. Sometimes you have 3, 4, 5, 10, 15 also. So we have to analyze that as well. Got it right? So when I look at it, I got a clarity that what here I need to apply a new operator. Here, this is not using companion object in the behind the screens. You can see so far on what are the collections we have used, it is using a companion object, but not this, or a companion class. They might be using that, but not this. It needs a new here. And again, you can ask, how can I add elements? And right, one more thing, don't try to blindly add elements here, like in previous cases. Okay, I added it. You can see another here. Now, why? Again, you have to look into the construct. This construct is not accepting any parameters. Look at this. This is a default constructor. No parameters in this. Means whenever you have some issue, you have to come to that constructors and you have to check the parameters. Here, like what is the this signature. You have to see the signature here. Based on signature, you have to see like whether to add elements or not, or based on suggestion of method or constructor, you should do the things. Now, then you can ask, how should we add? For that, they have given us, right? What is that? Push is there here. Happily, I can use push. I can add multiple elements with push. Okay, I'm doing all that in one go. I don't want to just one by one. This is giving an idea. Okay, I have done push, but this guy is probably I can add how many? Max 3 app. So another. Let me just check the element. Okay, this buddy is expecting again type, folks. No, right? Say taking nothing. That's you have to interpret like this. No issues. Now error is removed like that. Now 1, 2, 3, 4, you can add multiple elements because method is accepting parameters. We don't have a problem. But this buddy is accepting type. So just give what it requires. Now just print it. We are very much interested on pop. We can also try pop. So if you want, you can check pop also. We had a discussion the other day. So this is a simple analysis. Got it right? And every method you can see they were working on synchronized stack, not a normal stack. Okay, these methods are something which are exclusive works on this. You can see that. So what happened to our data now? I don't get 1, 2, 3, 4, 5, but I'm getting 1 to 2, 1. Something happened. Means internally there is a bit compression happen. I'll do one thing. Let's not go like that. Probably when I try to add multiple elements, there's a kind of compression happen if I'm not. You don't need to go into that details again. Again, that will be one more workaround. So let's add it in this way. Probably I'm expecting this should work. You see that? So might be you can ask me, sir, when we add more multiple elements in one method, in one push, what happens? It's like in a three-seater, right? By you put 5 people, what happens? You have to adjust yourself. Probably in the process of adjusting, you can see even the values got converted. That's what I personally understand, but I'm not sure. I don't want to conclude that, but as per my experience, that's what happening on that single push method. Understood? But I'll just check on that if it is correct or not. But go with this process, okay? So this is giving you the right results, right? More than that, this should be fair for us, okay? Got an idea? This is a simple idea about what is that, sir? synchronize stack and with thread safe stuff. That's what you need to understand. Other things are same, sir. Push, pop, pop. You can also apply operators, plus equal to minus equals. You can also try that stuff. Okay, check it. If they're working, it's well and good. Otherwise, you can ignore it. That's how things work for us, sir. So, are you good now, sir? Got some idea? Probably tomorrow, what we do is we take it. No, we convert. We discuss again. We'll finish off this and switch to the next topic. Probably I might start set tomorrow. I don't need much time on this. We will switch to the set hierarchy tomorrow because we have spent enough time on this mutable list. So probably today is 23. We are planning our Spark from July 1st. Of course, Scala classes continues on weekends. If you wish to, what is that? If you wish to improve your skills, you can keep attending. Nowadays, wherever you go, the importance of programming again had grown. So you can see, you go to the data science, there is a lot of importance to the algorithm building, right? That logical regressions, which we learned in school days. A theoretical thing we are implementing through Python or through R language, more than Python, people prefer R. The same thing you can do in Scala also. Got it, right? So slowly what happens is nowadays, in the interviews, in the JDs also, what I'm seeing is in big data also they were expecting cloud as well as DevOps. Do you imagine this? They were asking me CA and CS. Continuous integration and one more is there is something for DevOps, continuous integration and continuous something else. What is that, sir? Deployment. Yes, CD, CI CD. That is what DevOps is doing. What testing people are doing now, we are automating with DevOps, and people are expecting big data guys to do that. Some people are asking me, you have to do this. Then I'm saying, why do you expect me to do it? I'm a big data guy for now because we need to upskill DevOps. Once we upskill, then okay, we say yes. So the advantage for big data people is one fine day we becomes all in one. We need to be in big data. This opportunity is more for big data people. Okay, you need to keep your foot in AWS. Sir, you can keep your foot in AWS. You can keep your foot in DevOps. And also, right, today I got a call from one company, and they were asking this Python with the AWS integration. I told I am not into AWS. Maybe if you give me time, if you give me on-job training, I'll do that. If you are okay for recruiting me. Yes, he told. And after that, they were also parallelly working with the data science projects. They were using AI. Now this is connected something to that part, data science also. See, if you can properly utilize this platform, big data, if we can, instead of saying you, because I am also part of this, if we can utilize it, definitely we have, no, we don't have a problem of recession issues or anything else. Okay, you got it right, sir. I'm just giving you sharing my experience. You can also share my experience in your experiences in our WhatsApp groups. Any questions now before this? And I'm also correcting the questions for you people, so that might help you to get more idea in the Spark as well, the entry question stuff, or like what kind of questions they were asking, and how to prepare for that, all that stuff. Okay. Right? Let's make this a good course for all of us. Good night, sir. I'll catch you on tomorrow. Okay? If any session is missing, nothing to worry. We will catch it up on weekends. I will take a session on weekend. We'll spend time. Thank you.